How do atomic bombs work? On 16 July 1945, the first atomic bomb was tested in the New Mexico desert. The explosion was massive and the equivalent to 18,000 tons of TNT. Scientists figured that the temperature at the center of the explosion was there 3 times hotter than at the center of the sun. The atomic bomb, the most powerful weapon ever built by humankind, has captivated the population for nearly a century now. But how do atomic bombs work? What's the science behind the most dangerous weapons ever built? What exactly is nuclear fission, and how worried do we really need to be about nuclear war breaking out? Atoms, which are the building blocks that make up life as we know it, consist of a positively charged nucleus surrounded by a cloud of negatively charged electrons. The nucleus itself consists of protons, which have positive charge, and neutrons, which have neutral charge. Because particles with the same charge repel each other, the nucleus needs something to hold it together. This force is called the strong nuclear force, and without it, the nucleus would break apart as the protons repelled away from each other. The process of the nucleus of an atom splitting apart is known as nuclear fission. What is nuclear fission? In nuclear fission, an unstable atom splits into 2 or more smaller pieces that are more stable, lighter nuclei, and release excess energy in the process. The fission process also releases extra neutrons, which can then split additional atoms, resulting in a chain reaction that releases a lot of energy. Nuclear fission is generally possible in elements with an atomic number of 90 or higher. How can atomic fission be induced? At the core of nuclear weapon is a device called neutron generator. This is usually a small pellet of the elements Beryllium-9 and Polonium, which are kept separated by a piece of foil. When the foil is broken and the two elements come together, the Polonium emits alpha particles. The alpha particles collide with the Beryllium-9 and cause it to release a neutron. The neutrons fly off and collide with the uranium or plutonium fuel. When a single free neutron strikes the nucleus of an atom of radioactive material like uranium or plutonium, energy is released when these neutrons split off from the nucleus and the newly released neutrons strike other uranium or plutonium nuclei, splitting them in the same way, releasing more energy and more neutrons. These chain reactions spread almost instantaneously. Nuclear weapons are designed so that the reaction doesn't stop until all of the fuel has been donated and all of the energy in the atom has been released. The process of nuclear fission is a chain reaction. At each step, energy is released, and after the all nuclear fuel like uranium or plutonium atoms are split, the huge amount of energy released. What is nuclear fuel? The elements which used to make atomic weapons are called nuclear fuel. While a number of elements are fissionable, only a few are used in nuclear weapons. Most common are the isotopes uranium-235 and plutonium-239. Uranium is highly radioactive and is heavy enough to make atomic bombs. However, it's not actually the normal form of uranium that's used in atomic bombs. Instead, a sample of isotope uranium-235 is used, which has 3 less neutrons than the common form of the element. This isotope is used in favor to others because of its ability to readily absorb an extra neutron. Nuclear weapons can also be made out of plutonium-239. It has similar fission properties to uranium, so it can be used as an alternative fuel source for atomic weapons. The atomic bomb that was dropped on Japanese city Nagasaki during World War II contained plutonium instead of uranium. How powerful are atomic bombs? The first test that the world got of the power of nuclear weapons was in August of 1954, when the United States dropped 2 atomic bombs onto the Japanese city of Hiroshima and Nagasaki. The effect was devastating with an estimated 146,000 people killed in Hiroshima alone, and the city is almost completely destroyed. The first test of atomic bomb released an amount of energy approximately equal to 20,000 tons of TNT. That was over 60 years ago. How the most powerful modern atomic bomb ever detonated, the teaser bomb was 3,000 times as explosive as the one dropped over Hiroshima. The effects of nuclear weapons. If one of these bombs were ever used, the effect would be catastrophic. The heart of a nuclear explosion reaches a temperature of several million degrees centigrade. Over a wide area, the resulting heat flash literally vaporizes all humans, animals and trees. People inside buildings or otherwise shielded will be indirectly killed by the blast and heat effects as building collapse and all inflammable materials burst into flames. Those in underground shelters who survive the initial heat flash will die as the all oxygen is sucked out of the atmosphere. Outside the area of total destruction, there will be a gradually increasing percentage of immediate survivors. However, most of these will suffer from fatal burns, will be blinded, bleeding and suffering massive internal injuries. Survivors will be affected within a matter of days by radioactive fallout. Radiation-induced cancer will be affect many, often over 20 years later. Nuclear weapons cause severe damage to the climate and environment on a scale incomparable to any other weapon. The Red Cross estimated that 1 billion people around the world could face a starvation as a result of nuclear war. So I hope you learned something in this video. If you have any question, please type in comment section and share with your friends and family to support me. So see you again in next video. For then, bye bye.